Hello everybody, this is the second part of the video. Now I'm going to do from problem number 5. So problem number 5 is saying that a clay soil has a void ratio of 0.9 when the overburden pressure is 4 kSF. If the void ratio decreases to 0.64 when the overburden pressure increases to 24 kSF, the coefficient of compression Cc of the soil is, that's what is asking here. You know that when you draw that E log P curve, this is your log pressure and this is your void ratio. Then basically for normally consolidated soil, you see this one is like this. The slope of that thing, we call that one actually. Slope is basically your Cc. So which is basically E1 minus E2 divided by log sigma 2 by sigma 1. So if you take 2 points here, let's say this is point 1, so this is your P or sigma, actually this is your sigma. So if you plug that one here, then basically you will just get this equation. Let's say 0.9 minus 0.64 divided by log (24 by 4) .33. So the slope of this line is actually 0.33. Okay, but you have to be very careful that all the time actually when we draw that figure E log P curve, then basically from the name you can see this is actually log scale and this is actually normal scale. Anyway, so move forward. Problem number 6. Problem number 6 is saying that an undisturbed soil sample is collected from a 4-meter thick clay layer that drains one way. 2.5 centimeter thick soil specimens prepared from that soil sample that took 2 hours for 90% consolidation in the lab, which drains both ways. The time required for 90% consolidation at the field site is here. Okay, now before I start doing that one, then basically I'll just explain a little bit about like draining, how the one side draining and both side draining, like will affect your consolidation. So let's say there is a soil here. This is my clay layer which will undergo for normal consolidation, and let's say this is a impervious soil or bedrock. So in that situation you can see the clay layer can drain only this way, one way. In that situation, the HDR, which means the maximum drainage length. So you can see the water here has to travel all the way to here. Okay, so if this one is H, height of that layer, then basically your HDR would be equal to your H for single drainage. Now let's say the other case is here actually you have no bedrock, but you have another sand layer here. In that situation, we'll see that this one will drain both this way and that way. So that's the both way drainage. Now what will happen of your HDR at that time? HDR is the maximum distance that the water will travel to get out of the specimen, okay? So let's say if a point here, this one will not go this way. This one will go this way, okay? So the point at the middle of the layer, it can go either this way or that way. So the maximum drainage length, HDR, would be actually H by 2 for double drainage or both way drainage. Okay, now this information might be important to solve the problem number 6. So we know TV is equal to CVT divided by HDR square. Now if I talk about the lab, for lab specimen, if I use this one, then my TV for 90% consolidation, actually you can get your TV from your book, table number 11.8 from there. So you can see for 90% consolidation, your TV would be equal to 0.84. So you can see if I, for the lab soil, if I use this equation, that would be 0.84 is equal to CV T90 at lab divided by HDR at lab square. So if I plug all those values here, actually I don't have the value for CV, so I can say like this is 0.84 is equal to CV So lab specimen is 2.5 centimeter and it drains both sides. So HDR would be 2.5 divided by 2 square. and basically your T90 is given, which is 2 hours. This is in hours, this is in centimeter. Now let's do that one for your field. Field divided by HDR square. So you can see here this one is also 90% consolidation, so this one will be, since this is the same soil, because you collected that soil sample from the field, so basically their CV has the same value. Okay, so we are talking about the same CV here. I don't know the time here at the field. HDR would be, that's the one way, like drainage, and the thickness of that layer is actually 4 meter, so 400 centimeter. One way HDR would be equal to your H. So you can equate these two equations. Let's say this is 1, this is 2. So I can say CV into 2 divided by 2.5 divided by 2 is equal to CV T90 at field divided by 400. Right? Because both of them are 0.84, 0.84. So you can see I can cancel CV here, and the only unknown is T90 at the field. So if I solve that one, then basically I'll get $23.3 years. So basically your answer is C here. Anyway, let's move forward. Problem number 7. That needs a big figure here. I'll just draw that figure first because that would be much easier. Actually 7 to 11. All the problems, they have just one figure here. Basically that's your groundwater table. You have 1.5 meter here. This is 2 meter here. And this is 10 meter. That's basically your clay layer. And the gamma set 16 kilonewton per meter. 16 kilonewton per meter cube. Here this is sand, and this basically it's not saturated because it's above the water table. and your gamma here is actually 18.5. And this is saturated sand. So here the gamma sat here equal to 19.5. Now what is given here and what is not given here? So you were trying to build something here, proposed construction here, and they gave you that the new load coming from there is actually 57.6. They also gave you the E naught initial void ratio before you start doing that construction is actually 0.66, and your pre-consolidation pressure sigma C prime is 250 kPa. Now, problem number 7 is asking, like, if a piezometer is installed at point A, how high the water will rise above the groundwater table when the soil is 50% consolidated. So 50% consolidated, actually you are putting that one here, somewhere here, point A. So when this one is 50% consolidated, means like the 50% with 50% of the original load or total stress will be taken by water and 50% will be taken by the soil. Okay, so if you apply 57.6 kPa, then basically your pore water pressure at that time would be equal to 50% of this, so 57.6 multiplied by 0.5, which is basically 28.8. So if you try to see that how much this one is going to be at 50% consolidation, then basically gamma WH is equal to 28.8, so HW would be 28.8 divided by 9.81, which is 2.94 meter. So if I ask that question, like, hey, what would be that height of water when the consolidation occurs or the consolidation is completed? So you can understand that when the consolidation settlement occurred completely, at this time your excess pore water pressure will be 0. So basically this one will come back to here again. Okay? Now number 8. Number 8 here is saying the current effective overburden pressure at the middle of the clay layer. Actually, you can take the overburden pressure here and then here and make the average, or you can take at the midpoint. Actually, the other books, like they also suggest that you make like if you have a big layer, let's say 10-meter layers here, you can just divide that on 5 layers and take the middle of each of the layers, sub layers. But I think that the answer would be pretty similar, like not that significantly changed. So to take the advantage of that, I'll try to suggest all of you to just consider one layer, no sub layers, and then try to find out the overburden pressure at the middle of that clay layer. Okay? So here, that's what they are asking here. So you can either do two different ways. So your effective stress would be equal to, let's say I have 3 layers here, 1, 2, 3. This one is not submerged, but this 2 is submerged. So if I add from the top, then I'll say gamma H, so 18.5 into 1.5 plus this one. So here this one is submerged, so I have to take the weight of the water out from there. So that's the gamma submerged multiplied by the height. Then this one here is also submerged. So the unit weight would be 16.0 minus 9.8, middle of the layer. So that's actually 5 meters from here. So I'll just put 5 here. So this one is basically 78.2 kPa. Now you can do that one in a different way. You can just find out the total pressure and subtract the pore-water pressure there, and you can get this effective stress in the middle of that clay layer. Now how can you do that one? Let me show that one to you. So what would be the total stress? If I talk about that from the middle of that thing, then total stress would be any weight above that thing here, any weight that's going above, like per square meter area above this point to the surface. Okay, so this one would be include everything, like water and everything. So that would be 18.5 into 1.5 plus 19.5 into 2 which is actually 146.8 kPa. Now you can find out the pore-water pressure here. So the pore-water pressure would be gamma W into HW. So you can see the height of the water table from here to here is actually 5 plus 2, so 7 meters. So you can see that would be 9.8 multiplied by 7, which is 68.6 kPa. So your effective stress is equal to your total stress minus U, which is actually 146.8 minus 68.6. That's actually so this is basically the same answer you got, but with a different methods. So you can just follow any of that methods you want. Okay, let's move forward. that one here. Okay, so problem number 9 is asking the total primary consolidation settlement when the compression index CC and CS swelling index is 0.25 and 0.08 respectively. Okay, so first of all we have to check that whether the soil is normally consolidated or over consolidated. So if you can check that one with your normally your current overburden pressure. We already did that 178.2 kPa. So you can see in the past the soil has been compacted with 250 kPa, but the current overburden pressure is 78.2. So what kind of soil is that? Is it like compacted in the past with a higher pressure than this one? Yes. So basically this is a over consolidated soil. So we can say since the soil is over consolidated. Now we have to check again that like after adding that load here, whether this one would be more than the pre-consolidation pressure or not. Okay, so now what we have to do, we have to just take a look like del sigma prime plus is equal to 57, 78, and 57.6. Now you can see this one is actually, this 2 is actually smaller than your pre-consolidation pressure. Right? So you can see if we add these two, we'll get 135.8, which is actually less than 250. So in that situation, actually you have to use this equation here. So SC So if this one is actually greater than that, then basically you have to use the bigger equation, longer equation, okay? The other equation given for normally consolidated, over consolidated soil. But if you can see for normally consolidated soil, you have just one equation for settlement. You have two equations for over consolidated soil. So you have to check this one. If this is less than sigma prime C or pre-consolidation pressure, then you have to use this one. if this is greater than sigma c, then you have to use the other equation here. Now if I plug all those values here, so you can see this one is 0.08. H is the height of that clay layer, or thickness of the clay layer. If you put that one, like in meter, then basically you will get your settlement in meter. If you keep that one in centimeter, then basically you will get your settlement in centimeter. So let's say here, because this one is in meter, the answers are in meters, so I'll just keep that one meter. You already got that one, 135.8, and you got this one is 78.2. This one would be 0.12 meter. So your answer is A. Now, this is very, very important to follow these two steps here. First of all, whether this is normally consolidated soil or over consolidated soil. Normally consolidated soil, this one has to equal to this one. Okay, this one has to equal, almost equal. Okay, in that situation we call that one normally consolidated. See, but if I see that the pre-consolidation pressure is higher than the weight of the soil, this means like in the past the soil was somehow compacted. So this is over-consolidated soil. For over-consolidated soil, you have two equations to find out your settlement. So first one is if the new pressure plus the current overburden pressure still smaller than your pre-consolidation pressure, then you use this equation. But if your new pressure and the current overburden pressure is greater than sigma c, then basically you have to use the bigger equation here. Let's say, for example, it's not related with this problem though, but just for discussion. Let's say the load that's coming from here is actually 200 kPa from the new building. It's a much bigger building now. So in that situation, you can see this one would be actually so this one is actually now greater than this. So if this is the case, then basically this is not the equation you have to use. You have to use the longer equation. Okay? That's basically the trick. Anyway, let's move forward. Number 10. So number 10 is saying the coefficient of consolidation CV is 2.15 into 10 to the power minus 3 centimeter per second. How many years it would take for 90% consolidation? TV for 90% consolidation is 0.84. So you have to take a look here first, because you know already that TV is equal to CV T (90) HDR square. So they gave you the TV for 90% consolidation is 0.084. Now if you see in this figure that whether it drains both side or single side, then you can see actually at the bottom layer there you have sand, dense sand here, So it can drain this way and it also can drain this way because there is sand here. So it drains both sides. If it drains both sides, then basically your HDR would be equal to H by 2, which is 10 meter divided by 2 equal to 5 meter. Okay? So you can see here that this one, your value of CV is basically 2.15 into 10 to the power minus 3. This is in centimeters squared per second. So if you use your HDR, let's say 500 centimeter, then basically you will get your T in second, okay? So divided by 500. So if you solve this equation, you get your T90, means like the time required for 90% consolidation is actually 3.1 years. So one of the most important things in this particular problem is to understand what would be the value of your HDR. So you have to check by yourself, like whether it can drain both ways or single ways. So if you see that there is actually impermeable layer or another clay layer very, very stiff than this one, then basically you might have to consider that it will just, drain only one side. Anyway, let's move forward. Number 11. Number 11 is saying that the excess pore water pressure at the point where the degree of consolidation is 60%. Okay? So excess pore water pressure is, what is the excess pore water pressure? Okay? So we know that here U is equal to 1 minus UZ divided by U naught. So that's actually for 60% consolidation, this one is 0.6 is equal to 1 minus UZ divided by U naught. What is U naught here? That's the most important thing, right? U naught means that the pore water pressure at time t equal to 0. But from the theory we know that at time t equal to 0, all the imposed load will be taken by the pore water pressure. So I'm going to add 57.6 from the new construction. So at the beginning, your U naught would be equal to 57.6 kPa. So if you plug that value here and solve for UZ, the pore water pressure at that particular point, then you will get 23 kPa. So one more time, that how you know the U naught. U naught means like the pore water pressure at time t equal to 0. But for consolidation settlement, we know as soon as we apply the load, all the load will be taken by the pore water pressure. So at that time t equal to 0, the pore water pressure should be equal to the pressure that's coming from the new construction. Okay, let's move forward. this one is for actually problem from 12 to 15. So this is clay layer, and this one has a gamma sat 115 pound per feet cube. This is sand. This is sand here. Here is your groundwater table. So gamma sat here. £120 per feet cube. Here is the same sand, but this is not saturated, and this one is 110 pound per feet cube. Four feet, 8 feet, 6 feet, 4 feet. There is impermeable layer here. Now the first question, this one is saying that after the construction of a foundation on top of the soil profile shown above, it took 3 years to get 70% consolidation at point A. So point A is basically here, the middle of the clay layer. And you have a piezometer here. So before applying any load or any construction, this one has to be here because this is your groundwater table, right? So it's saying that after the construction, 3 years after the construction, 70% consolidation occurred at point A. The piezometer installed at this point show an excess pore water of 4 feet. Okay? So your UZ feet. So number 12 is actually saying the total pressure under the foundation. Okay, total pressure under the foundation. Actually asking what is your okay, but we know like just this one is equal to actually U naught. U naught means the pore water pressure at time t equal to 0. Now this one is saying that it took 3 years to get 70% consolidation at point A. So if you use this equation that U is equal to 1 minus UZ divided by U naught, so this one is 70%. Four feet of water So you can solve your U naught here, which is basically 832. PSF. Okay? This means like actually the total stress that coming from the newest should be equal to your U naught is equal to 832 PSF. So the answer is D here. Okay? So I'm just trying to do that one in a reverse order. The other case, this one is given and we ask like, hey, after 70% consolidation, what would be the pressure here? Now we are asking a question a little bit in a different way. We are saying that after 70% consolidation, the pore water pressure is here. So how much pressure coming from the foundation here? Foundation here. So that's actually 832. Anyway, let's move forward. Then 13, problem number 13. It's saying that 3 years after construction, the pore water pressure at point A is pore water pressure, not the excess pore water pressure, okay? The pore water pressure. So the pore water pressure EU, that would be equal to pore water pressure because of this height plus, so EU plus, let's say EU due to overburden plus the excess pore water pressure that's coming from the structure. So you can see this one doesn't change. You see this is 11 feet here, okay? So this one would be 11 into 62.4 plus the excess pore water pressure. So we already know the excess pore water pressure from this one is coming only this much, okay? So that's actually 4 into 62.4. So if you add them together, then basically you get 936 PSF. So after 70% consolidation, you will see that the pore water pressure is now actually 30% and 70% will be taken by the soil. Means like the effective stress, right? So pressure due to this one has changed. On the other hand, the pore water pressure because of the groundwater table remains same. So the total pore water pressure at A would be equal to the pore water pressure because of the water head and the pore water pressure that's coming from the new structure. So you can see as time goes, the consolidation settlement occur will progress and this excess pore water pressure will be 0. So eventually this one will come back to this value here, okay? Now let's move for number 14. This one is saying that the 3 years after construction, the effective stress at point A is, so what would be the effective stress? So first of all, you know the effective stress here because before the construction. This one is remaining here. And then you also see that how much pressure is coming from this new construction. So eventually, like when all the consolidation will occur, then basically this one will be the pressure from here to here as well as the total of this thing here. But after 3 years, when 70% consolidation occurred, during that time your effective stress at A is equal to effective stress from soil plus the effective stress that coming from new construction or from the foundation. So this one is basically, you already know how to find that one. This one is actually 4 into 110 plus here 120 minus 62.4. The height is 11, actually 8, sorry, plus that's actually soil, due to soil, plus 115 minus 62.4 multiplied by 3, because this is 3, total is 6, and this is the midpoint, so that's actually 3 here. So this one is basically 1059 psf. Now, if you want to find out this one here, so after 3 years, 70% consolidation occurred, which means like 70% of the total weight will be taken by soil and 30% will be taken by water. Okay, so if you take 70% of that load coming from here, so your effective stress from foundation after 3 years, that will be 0.7, multiply the total stress that coming from, that's actually 832. So total is 661. So your effective stress at point A, that would be basically this plus this. So 1059 psf plus 661. So total is 1720. Okay, so basically the effective stress from the soil is not changing until the water table moves. If the water table remains at the same location, then basically your effective stress from the soil remains same. On the other hand, your effective stress starts from 0 as soon as you start this one and goes finally to this number here. Okay, so this one changes with time. Anyway, let's move forward. Now number 15, which is the last problem of this worksheet. So 15 is saying that the coefficient of consolidation of the soil is, what is the coefficient of consolidation? Okay, so we know that already given this information that your T70 is basically 3 years. Which is so which is actually 365 into 24 into 60 into 60, that many seconds. And what is the HDR? So we have to see that this is sand here, this is sand here, the clay can drain both ways. So your HDR is actually H by 2, means like 6 by 2 is equal to 3 feet. Let's change that one to inch because our units are in inch per second, inch square per second, so that's actually 36 inches. Okay? So we know PV is equal to CVT so if you solve for your CV, then this one will be TV for 70% consolidation is 0.4, which is given. If not given, then basically you have to take like table 11.8 in your book to find out what would be your TV for that. So that would be TV that's basically your CV would be 5.5 into 10 to the power minus 6 inches square per second. So your answer is C. So that's the end of this session. I hope that you enjoy that one. If you have any confusion or any explanation, please Skype me or FaceTime me. You know, like I already posted that information in your Blackboard, and let me know if you have any questions. Okay? Thank you so much for your attention.